Nästa föreläsning kommer från Middlesex University och den hålls av professor Mehmet som är Head of Engineering Department på Middlesex University. Mr. Mehmet, can you hear us?
I can indeed. How are you?
Yeah, good. Welcome. Very nice meeting you. So this is Mr. Professor Mehmet. He's going to talk about robots and what's coming. So,
I'll do my best.
Yeah, please go ahead and yeah, good luck.
Thank you. I'll see if I can share my screen. Just a second. So there's multiple screens, so that's that. I think let's share my screen with you. That should now be visible to you. And the presentation. Now, can you see my title on the screen? Okay, thank you. Well, thank you for giving us the opportunity to talk about robotics. Quite a lot of find this robotics interesting. So this is going to be a talk about what robotics is currently at and what the future holds for us in terms of robotics. And my talk is really based on types of robots that we currently have and we will have in the future, the direction of travel in robotics, what opportunities those robotics will bring to us as individuals, young people, and then also looking at what study options there are in robotics as a field for the future. So that's the content of my talk. And I'll try and give you some examples. If we look at in terms of the types of robots that are currently around, initially we only had industrial robots and we used to classify them based on their geometry. It was Cartesian robots, spherical robots, etc. But these days we have a lot more other robots around rather than just industrial. So industrial robots classified in terms of just standalone. You can see some pictures on the right-hand side with orange robots on a production line. But recently we also have robots that are developed into more collaborative approaches where they're no longer in cages or safe areas and they can be with people assisting in work. We're also seeing new areas of social robotics or service robots, which are not necessarily humanoid, but also non-humanoid as well as service. So you can see on the right-hand side a little robot used for vacuum cleaning a house, for example. And we also have some specialist robots that are developing in areas like medicine, what they call surgical robots, or agriculture, as well as the UAVs or unmanned air vehicles. So all of this gets under the title of robots, and I'll go through each one of those three sections and give you some examples of where the state of play is. So industrial robots, he hasn't quite grown as much as he should have in the past. But if you look at the more recent figures, there is currently about 2.7 million robots, industrial robots, operating in factories around the world. But as I said, only recently that has actually increased, 85% increase we've only seen in the last 5 years. And it's becoming quite a large a sector in terms of revenue or value in installations. So looking for close to $14 billion industry. And 73% of that investment is actually taking part in 5 countries like China, Japan, USA, Korea, and Germany. So those are the most countries that actually have the biggest number of robots. And if you look at the number of, or the density of robots around the world, and we look at the employees, if you divide the employees by groups of 10,000, and for each 10,000 employees, there is 113 robots worldwide. Obviously, these are concentrated more around different countries. For example, if you take the same measure and look at the top 5 of dense robots, industrial robots in the world, you'll see the five countries. Singapore, by population-wise, tops the biggest density. They have 918 robots per 10,000 employees, where in Sweden, that's down to 277. It's significantly more than UK, you might say. So that's the sort of the landscape in terms of how widely industrial robots are, and also the trends. So there's a big increase in terms of adopting industrial robots. This information comes from the International Federation of Robotics that was published this summer in August. Now, the other side of the coin for the industrial robots is that collaborative robots. Again, these are used to assist in the workplace, in industry. In a picture, you'll see a worker working with a universal robot, UR5. That company is based in Canada, I believe. And they make those silver tube pipes. It's quite clever in terms of how it works, but physically, it doesn't look like a robot that most people would associate with. But it is exactly one of the smartest robots we currently have in terms of collaborative working. And the collaborative robots are actually going to be the future in terms of robotics, and it's expected to hit $100 billion US market in terms of value. They offer several advantages opposed to industrial robots. They no longer need a protective environment. For example, they don't have to be in a cell. They can just be in a workplace with other people around them. And a lot of companies use these because they do not need a specialist labor. For example, untrained people can still use these robots to program them because they're task-led. They can just remember what you show them that they should do. And they often complement human-led operations. So Sweden actually is quite good at this, and I'll give you a quick video in terms of how this is used in practice. This is a clip from ABB Robots. Yeah, but we'll see. Let me just see.
Yumi is 5 years old this year, and in the 5 years since ABB's collaborative robot was introduced, it certainly proved a tasty treat for the public, conducting operas, starring in music videos, and meeting a host of world leaders. But Yumi is about so much more than just eye-catching photo ops. For industry, the advent of a truly collaborative robot working alongside human staff has been little short of a revolution. Before Yumi came along, robots were typically corralled inside protective cages or behind safety barriers. Yumi's different. With an ergonomic, human-centered design, padded arms and motion control software, it can be installed in workstations alongside people, working collaboratively on tasks with human colleagues. And lead-through programming means it can be programmed in minutes by someone with no specialized training. That all makes it ideal for material handling and assembly jobs, while its accuracy has meant Yumi has found a place in medical research too, increasing hygiene and efficiency. The Yumi family has continued to grow. The concept of a mobile Yumi has been tested, and there's also a single-armed model that can be mounted on tables, walls, or ceilings. Yumi led robots out from behind the barriers, and it's now looking forward to another 5 years of human-robot collaboration.
There we are, just celebrating with those successes from Sweden, but I think they're also manufactured around the world, particularly in Poland, but they're sold globally. And we also have research centres within UK using this. And at Middlesex, where I work, we also have several of these robots as well. Alongside the industrial robots, now the new category of robots are called the social robots. And these tend to be seen in non-industrial applications such as personal assistance and customer services, and more in terms of healthcare. I'm not talking about entertainment robots. These are actually used for daily supportive activities. And a lot of the developed countries are now preparing to invest into social robotics, particularly for healthcare applications and caring for people. So, and also show you some of the videos we currently have of work that is taking place at Middlesex with other collaborative partners around the world, including Sweden. The challenge with the social robots is the expectations from us, because we expect them to behave like humans and have the same human interaction. But to do that, you need artificial intelligence, which is still not good enough. It is still being developed, but the progress we're making in that is encouraging. But we still have some time to go when we put the AI into the real world. In the lab settings, it does work, but in real work situation, it is still in its infancy. So the next video I'm going to show you is a project called Caresses. This is a European funded project across 8 different institutions from Europe. That will be sort of Sweden and in Hungary, in UK, and also in Japan. So the purpose of this is to look at culturally aware robots and how these will be developed in cases where we look at the healthcare and how this can be helped to deal with people, in particularly elderly. This is quite a little bit longish video, so I'm going to play it a little bit at the beginning and then skip it and give you some examples at the end. Oops, it says.
Which monument is in this photo? It is the Westminster. Oh, wait a minute. Big Bang. That's correct. Well done. Thank you. Do you want me to play for you one of the highlight scenes of the movie The Lady Killers?
Yes, please.
Great. Let's do that. Tell me what kind of situations make you feel happy. Lovely, lovely to be with Pepper. I'm very cheerful lady. I love children. I'm happy to surrounded by the children. I like lovely music. I don't like to be alone. Because I born in a very big family. I know that many children were evacuated from British cities to the countryside during.
I finished, and it's been lovely. I had some music that you may have heard. I had Chuck Berry, and then I had the Pearl Fishers.
Oh, that's
classical. Absolutely beautiful.
I told to my children that I have the company of Pepper. Pepper is so adorable, and he is a very good companion to me.
mean, yes, the previous example you saw the how a robot, or the Pepper the robot, is actually interacting with the elderly and then in care homes. And one of the issues to do with loneliness, people, I mean, you saw the lady talking to, having a conversation with Pepper about how she doesn't like being left alone and growing old on their own. So that these robots are now becoming more and more used in sort of homes and care homes, looking at elderly, whether they're just having a conversation, keep them busy, keep the interactions going. And it is used in that sense, and then also being accepted. Because remember, the people that in that situation are actually not really grew up with the technology, which is all quantum, but what they do understand is human interaction. And these machines are actually serving in that sense. The third category of the robots that I indicated was the specialist robots, and I listed one of those medical or surgical related robots. These tend to be in assistive mode. So surgical robots, we currently do not let robots to operate on a human by themselves. They're always assisting a surgeon, and a surgeon is in control of the machine. But it does give us more precision and repetitive operations when if it's just left to humans alone, then there'll be a sort of fatigue that sets in that isn't always good. So in terms of getting consistent sort of and more or quicker recovery, this is why we use them. We can see these happening in rehabilitation in terms of after surgery. Common forms of these rehabilitation robots takes exoskeleton configuration to assist with maybe walking or movement or sensations in terms of limbs. And care robots, there's a new science developing in terms of human support robots, HRS. These are going to be more common in the future. Many other companies are now investing into this as an area. The next clip is actually showing you Guy's Hospital in London, how they use their medical robots. And this is from one of the surgeons that operates this machine.
I'm Ben Challicum. I'm one of the consultant neurologists at Guy's, and I'm also one of the robotic surgeons. So the robotic surgery program at Guy's and St Thomas's has been going now for 13 years. It's the longest program in the UK. Almost 3,000 patients have been treated with robotic surgery here. We treat mainly prostate cancer in terms of the highest percentage, but also have a very strong program for both bladder and for kidney cancer, and for some other rarer cancers that we see within the urological group. So robotic surgery is really just a variation on standard laparoscopic, i.e. keyhole surgery. It uses the same small holes in the patient's skin, the same small scars, but instead of long, straight instruments controlled by the individual surgeon that can kind of just go left and right and up and down, little tiny arms go in that are controlled by the surgeon but away from the patient. These arms have actually got a higher range of motion, and they're connected to a machine called the robot, and the surgeon actually operates from a console that can be several meters away from the patient. Robotic surgery has many patient benefits, really from the point of view of the minimally invasive aspects of the surgery, so obvious things such as quicker recovery, smaller scars, less blood loss, less pain, earlier return to work and less stay in hospital. But also we think that there are some aspects of the operations that we can actually do much better with a robotic approach than either a laparoscopic and occasionally also than a traditional open approach, because really of the dexterity of the robot and the precision and the three-dimensional vision that it gives you. So we really have all of the technology at our fingertips to provide the best treatment for our patients.
Yeah, so that's the case in terms of robots in medical fields and how this is used to assist surgeons, and also for the benefit of the patients, so it's quicker recovery. The other areas of the growth is in specialist robots is the UAVs. These are unmanned air vehicles. They're not always called a drone. UAVs is probably a more generic term. And we're expecting these this type of robots to increase. currently there are not many around in use. They're in labs, but they're being also tested in the field. But we're expecting to see around 2.5 to 2.6 million units by 2022. And many logistics companies are now looking at this as another way of distributing goods around the world and around particular countries, particularly congested areas. You may have known the company called Amazon, which is quite prominent in the way that is now shipping around the world and also countries, particularly in this current pandemic period. They've teamed up with an American company called AG Eagle Aero Systems. AG Eagle actually makes agricultural robots, but they have quite a prolonged know-how in drone logistics. And what we'll be seeing shortly, in a year or two, that there will be deliveries that will be coming by using drones, and that is projected to grow from 11.2 billion to 29 billion by 2027. So it's in the next 6 or 7 years' time. There'll be a lot of sort of drone-related logistics and transportation and in the workplace. And I think we're all going to see the impact of this shortly. So these are now currently, I know some of the work is being trialed in Cambridge around the Amazon logistics side. But it won't be before long that we will see actual deliveries happening through using these UAVs. And these are the companies that are actually considering drone technologies to deliver either consumer packages, food, or healthcare supplies or heavy cargo. So they're not all about fun. They're actually a serious element to what the UAVs will provide. And we expect the market to triple in terms of from what it is now to about 823,000 drones flying at any given time in the next 2 or 3 years. So yeah, I mean, look at the companies in terms of you might recognize these are, delivering consumer goods essentially, but there's also looking at heavy cargo with Boeing and etc. So that you're carrying people. So we will see drone taxis as well in some time and not too distant future. So the other area of specialist robots, so we talked about the surgical robots and the UAVs, but there's also a lot of work going on into agriculture. And the next video shows how that is put into effect. For example, crop protection is one of the key areas that we are using robots to help. So as you can see, that this is an area where there was a big sort of savings done, particularly protecting the environment. The amount of pesticide they spray is now down to individual weeds rather than a blanket approach. So where are we heading with all this? And I'm also conscious about the time, so I'll try and speed up a little. In terms of direction of travel, many companies are looking into predicting what will happen in the future, how the workplace will be affected. And an organization, technology organization called PricewaterhouseCoopers did a survey recently, and they looked at 29 countries and considered 200,000 jobs and how this is going to change. In terms of the increase, we're looking in terms of $15 trillion business. So in 10 years' time, AI, which is artificial intelligence, will have an impact that will generate something like a $15 trillion business for developed countries. At the moment, 3% of the jobs are under threat by automation. But in 10 years' time or so, by the mid-2030s, that threat is going to affect about 30% of the current jobs. But there are also going to be opportunities. But where the threat is actually, it's on the low education, low risk automation areas. So you'll see some of these areas being impacted, but there are also opportunities in growth areas in terms of how we will interact with the incoming technology and the benefits that it will bring to us. But we will need to change ourselves a little. And there's 3 phases of this. I don't want to go into detail, but in terms of what's happening now is an algorithm phase. This is looking at primarily automation of simple computational tasks. That's going to be increased by, let's say, late 20s, next 6-7 years time. We're going to see work that is going to be routine and repeatable. That's going to replace automation. But it won't be until early 2030s that we're going to be looking at autonomous AI and robotics. At the moment, we don't see actually much work going on with the autonomous. It's still the AI, as I said from the beginning, it's not developed sufficiently robust yet. So looking at future jobs, this is the analysis that was done last month from the World Economic Forum, looking at new jobs that are going to be emerging in the near future. One area I'm going to point out is that non-humanoid or industrial automation drones will be one of the significant increases in terms of robotics. So 62 or so % of the organizations that was surveyed, they will be implementing those technologies. But if you look at the top 2 or top 3 areas that's emerging, cloud computing, big data analytics, and Internet of Things are the biggest employment opportunities. I think we look at in terms of jobs. Those are the areas that we should perhaps consider. So what should you study if you want to go into education or higher education? What area would you go in? Well, intelligent automation is probably the area that you should be considering if you're interested in technology-led areas and you want to be part of that. The key thing is on intelligent rather than just automation. And to do the intelligent bit, you need artificial intelligence to develop sufficiently to enable you to do that. And if you're going to be working in that area, you need to perhaps study those areas. I don't want to sort of plug just Middlesex point of view, but you can study many of these subjects around the world. But in my institutions, we're now looking at it in terms of offering programs in robotics, mechatronics, which is electrical, mechanical, and software area, more generic design engineering. And there's a list of them. Cybersecurity and digital forensics is going to be one of the key areas as well. But if you're looking for undergraduate study, then perhaps a more generic program is more suitable, because by the time you finish that course, technology will have moved on. So you don't want to be tied yourself to 2 niche markets first of all, but you would do a generic undergraduate study. Might say, I mean, robotics is quite broad, but you'll want to perhaps do a higher degree in one of the more niche areas, whether it's going to be called the intelligent transport or mechatronic systems, or something that's just very popular at the moment is data science. What's going to happen with that is that data engineering will also appear as a new job in the future. Currently, you won't see any adverts looking for data engineers, but that is to come very shortly. So from us at Middlesex, I think I've eaten up all my time available, and I'm just going to leave you a short treat from our resident robot at our campus. And this is our Pepper. And Pepper would like to sing to you just to celebrate the time of the year and then see what you think.
The next song is the well-known Jingle Bells. 3, 2, 1. Jingle bells, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Jingle bells, jingle all the way. Oh, what fun it is to ride in a one-horse open sleigh. Dashing through the snow in a one-horse open sleigh. And the music riding all the way.
Thank you, Mehmet. I think we have to start
Okay.
The next song is the well-known Jingle Bells.
Thank you.
Thank you so much, Mehmet from Middlesex University. Tack så
You're
mycket.
welcome. You're very welcome.